Alright, so let's begin with our first video on structured text. We're going to talk about assignment statement. This is like when you have a variable and you have some expression. How do you assign that expression to a variable? So we have three examples here. First example, you say something like X motor colon equivalent to X sensor. This is something new to you. I can mention you that first you define a variable called X motor, and then you have another variable X sensor. So these are two variables, and X sensor is writing the information to X motor. So it's always from right to left. Never forget that. It's always from right to left. And in the second example, you can see result is another variable. This is getting the value of 100 multiplied by input value divided by scale. So this is now an expression made up of variables and some mathematics. Okay. In third example, you have another variable limited value, which is getting the information from a function here. So you can see that it's a function call. The function is minimum. So how we can do that? We're going to learn that in the future videos about function calls a bit later, because this is just in the beginning. I'm going to tell you the basics. So let's see how we can write some statements in structured text. In this case, I'm going to start with my project. So here I already have my PLC Micro850, and this you already know how to add a PLC from the previous lessons. I'm going to go to program and right click and add, in this case, structured text. So let's add a program, and then you have a program here and you have local variable. It's quite similar to what we were doing before, but now if you open this program one, you'll have a structured text editor. Okay, this is what I wanted to show you, how you can work in structured text. So if you see on the right side, you have the properties of what you're going to write here. For example, comments. The font of the comments, the color of the comments, and then you have the editor font and the editor color, which is like white background. If you want to change that, you can also change that to, like, say, a black background, and then once you want to type here, you can have a white, keywords. So for example, now if I type here, let's say X motor, and I press enter, you can see that it's black, okay, because the text is also black. So let me see, where is that? Editor font, editor text. I can change that to not transparent, but white. Oh, this is the background. And you can have the text somewhere. Could be this one, white. So now you have X motor as white, but when you select that again, it's white. So I would prefer that you play around with this one and find your best font and the best color. In this case, I'm just going to go with the default value. So I will keep it white and this one black. And I would like to write text like this. But you can choose any way you want. You can have a dark mode, which usually people do these days. All right, so this is the properties of your container. And then you also have the toolbox here. For example, you see here some pointers, some case statement, for statement, if else, repeat, and while. You can also drag and drop here if you want. Let's say if I want to use if else, I can drag and drop here. And then I have predefined syntax to write if else. Otherwise, you can also type by yourself. So these are the two windows which are related to structured text. And then if you go to local variables, there you can write your variables. All right. So let's begin writing a simple assignment operation. Okay. So in this case, let's say I can also maybe jump to the next slide where I have a tiny exercises for you. So first example, we're going to write a structured text for the following Boolean logic. X is equal to A dot B plus C. Use ABC X as digital ISO. All right. Let's begin with the basic one first, and then we will solve this example. So let's say I just want to use assignment operator. So before you write your code here, you have to first define your variables. This is very important. So I'm going to just split the screen. So drag and drop here. And now I have variables here. So let's say I'm going to use the word X motor. All right, here I want to highlight, when I write X here, this is like how you can name your variable. There are different rules and different ways how you can do that. One is like camel case and Pascal case, snake case, and Hungarian notation. So here, if I'm using X, I'm representing this variable as my Boolean, because Boolean I want to represent by X. If let's say I take here integer, and in this case integer would be, let's say, motor speed, and the first letter I want to use I, which stands for integer. So that's how I want to use my variable names. And when you see here, I use the first word as motor, and the next word is speed, but there is no space between that. This is something called Pascal case notations, how you can name your variable Pascal case. But if you want to put like underscore and put a smaller speed, this will be like a snake case. Okay. And if you want to just use motor, and here you can just use speed, this is like camel case. So there are different ways how you can name your variables. I'm going to use first as my data type and second one as my tag. And this X means it's Boolean. So my X motor is Boolean variable. I want to take another one, X start. This is also Boolean. Now let's say I want to actuate motor with the start input. How I can do that? Remember, the data flow is always from right to left. So on the left, we have first output. So I'll put X motor, and you can see that it's already defined. So it's already taking this from here. And then I will put X start. So you will always see your variable here. That's it. Now this coding means your start is actuating your motor. Remember, right to left. In ladder logic, it's left to right. So don't get confused. Here is always right to left. And if you want to write a comment here, now if you press enter on the top, and I can put like this, there's 2 slashes, and then I can write, let's say, logic to run the motor. That's my comment. And it's very important when you start your project, you can always define your project with comments. It's very useful and very readable. Let's say I want to write program, and I can type like this, or not the dots, like the minus, and I will say version 1.0, and I can say author Rajvir. Something like that. You can write some comments, and then you know, okay, this is the version 1.0. And let's say in the future you want to change this version. Let's say you want to have a not operation. I can put not here. This is like my inverse, and I change this. This will be then version 1.1. Okay, and then you can also write when did you make these changes. You know, this is just up to you how you want to define your variables and how you want to define your comments, things like that. Okay. And when you go to variables, this was like I'm using the local variables here at the moment. So let me just remove the not. So once you're done, let's see what will happen when you download that. So let's download this to our PLC. My PLC, I think it's already connected. Let me just verify. I think it's connected, but we will see. I'm going to download this to my PLC now. So basically I just have 2 variables, start and motor, and they are, the motor is actuated by start. So let's see, we download it now, which will take ages, as you already know. So, okay, its build is done, no errors, which is good. And my PLC is, I think, located already in my network. And really quick, we're going to download that. All right, after struggling a lot with the communication, what I've done is I have connected my PLC by USB. So before I was doing every time with Ethernet, and now if you see here my connection status, it's via USB here. You can see USB here. And how this is done, you just have to connect USB port to your PLC and to your computer. And then if you go here to connect, and if you go to browse, you will see here a USB connection, and then you will find your PLC. So sometime your network might have different IP address or subnet mask, and if you're struggling to set the IP addresses, you can also always use USB mode. So with USB mode, the downloading process is same. Just define your path here, and then you can just click on download, and that will compile your project, and then it will download that to your PLC. So it takes almost the same time as Ethernet, but it's more reliable in case if you don't have Ethernet port on your laptop, which is in my case. I have a new laptop without Ethernet port, so via Wi-Fi the connection was a bit slower because it has to route through the router. So I do with now a USB port. So now right now my program has been downloaded, and we just have a look. How does it look like on the PLC now? So here it is. We have my variables, and that's my structured text code. And now if I click on start, if I actuate my start, and you can see that my motor will be started as well. So this is basically going from right to left. So that was the basic way to write a structured text code the execution is from right to left and we have just two variables. All right, so let's make this exercise a bit more interesting. So in this case, let's go back to our presentation and see what do we have. The example 1, write a structured text for the following Boolean logic x is equal to a dot b plus c. All right, so we have a Boolean expression here, and then we have to use abcx as my digital IOs. So first, let's just do with our variable. So we take 4 variable in this case. So I'm going to just go offline and go to my local variables, which is here. So I have a and b. So if you know it's in Boolean, you can also write xa or xb. xc is also Boolean, and what else we had? A, B, C, and x. So I take 2 more variables. So this is the xx. All right, so it was like A, B, C, and x. So x is my output, A, B, C are my input. So this is saying we have to make a logic, which is a dot b. So your x equivalent to a dot b plus c. So you can see that here you can write your requirement in comment mode. And now we will write the code. So x is my output. So I'll write x here. And remember, when you are given a situation, here it says equivalent to, but in structured text, you write colon equivalent to, like this. Okay, this is similar to you also do in Siemens PLC programming in SCL. A dot B. Now, what is a dot here? Dot is an AND gate. So in this case, you can write. So here, first, I have to make sure I have a correct variables. So xx is my output. A dot B. So I can also write this bracket A. And because dot is my AND operation, I can write AND. And you can see that when you type AND, it's pink because it is reserved word. You can see that here the color is pink. You can also change that. And B, which is my XB, that's my B. And then you can close the bracket. And now plus. Plus in Boolean language is OR. So you can just type OR C, like that. That's it. In the end, semicolon. That's your structured text code for this equation. Okay, so this is done. Let's download that to our PLC now, and we can see the result, how this is going to work. Okay, this is a very simple Boolean expression. And remember that when you were doing it in ladder logic, you have to put the AND series and then in parallel, which takes a lot more time than structured text. And also in function block diagram, you have to use the blocks. You know, it's a time consuming to drag and drop the blocks, and then you can make a combination logic. Both will work, everything will work. It's just where are you saving more time and which code is more easy to read. For sure, in the beginning, structured text, it's a bit complex to understand when you are new to it, but if you know, if you're used to it, you can understand, okay, and or operation assignment, done. All right, let's see in which case the output will be on. Output will be on if A and B both are true or if C is true. Let's check with the C first. So if I actuate C, I have my output on, working perfectly. And now let's see if A and B both are true. So A, I make it true, B, I make it true, and my output is true. Super nice. So this is how you can, write Boolean expression using assignment statement. This is your assignment. This is what we learned today. And now, the second part of the code says, use ABCX as digital IOs, okay? So we were working right now with just variables, like local variables. Now there are 2 ways to solve that. One is you use ABCX directly as your digital IOs. Second is you move the information of digital IOs to ABC and X, okay? So I will show you the both ways. So I'm just gonna comment that here. Let's say we go to our global variables, and these are the global variables here, and I can assign this as an alias. So for example, my first input, I can write as A, and the second one, I can do B, third input is C, and X is the output. I will put it here, X. All right, and now I can write my code. So I can close this window, and I want to open my programming window, which is here on the half of it. All right, now what is my input? A. This is this one. So I can write, but first I need to write an output. For output, I can write, let's say, X, and you can see that just by typing X, it's automatically telling me this is defined as X. So you can just select this one. But remember here, you will see the actual name, not the alias, okay? And what you can do is you can now put an assignment. And now you have A. So in this case, I will just type A. This is my first input. And because it's AND, so I can type AND here. Now B. This is my second input, which is this one. You can do like that. Or with C, which is this one. So this is the equivalent when we are using PLC IOs. Okay? And here you can see that when you select on the tag, it has attribute. It's only read because we cannot write on the input. It's just read. And then this one is also read, this one is also read, and this is my output. This you can read and write. Okay, that's how you can show that. And now once you're done, you can just download that to your PLC and we will see the result in our trainer. Oh, there are some errors. Let's see what are the errors. Okay, I forgot to put semicolon. Remember, never forget the semicolon. This is going to give you a lot of headache. So now let's download that to our PLC real quick. There you go, download. And now I'm going to show you the result in my trainer because this I can't trigger in my software. So I have my first output, and the first output in my PLC trainer is this LED you can see on my trainer. Okay, that's my first output. And input 0, input 1 are this one, 0 and 1. And input 2 is this green light. So we have 3 inputs here on the top. So let's see if it works. So first I'm going to try with the input C, which is this one. So if I press this one, my output should be working. You can see that now my output is on the bottom. I think this button has some problem. So the output is on with C. And second task was if both inputs are true. So this one and this one. And you can see that output is true. And if you want to see the global variable here, you can see that if I press A, you can see that A is here. If I press B, and my output is on, right? If I press just C, then also my output is on. So that's how you can verify your outputs using direct addressing. This is one way to do that. There is another way how you can solve that. In this case, I will still go to my old logic. I will use my variables, and then I will assign this IOs to these variables. For example, my A and B and C, these are my inputs. First, I have to read the inputs. So I can type here a code, read inputs. This is totally your way how you want to do that, but I prefer doing like this. So read inputs. So my input XA, I can put here, is taking the signal from this one. Copy, paste, right? And XB is getting the signal from this one. Similarly, XC is getting the signal from this variable. This is my PLC input. So first I read my inputs, and then I solve this logic, and then I write my outputs. So write output means this will give solution to this XX, and this is in the end going to give solution to this one. I will copy this one here, like this. And then I don't need this code here, I can comment that. Now what's happening here? If I press first input, it goes to XA. If I press second input, it goes to XB, or the status of these inputs goes to XC. So in the first scan of PLC, because PLC is going to scan this code from top to bottom, so it will first assign the status of these 3 here, and then it will solve the logic, and then it will assign the output. Very simple. Let's see if this works. So I'm going to download that to my PLC again. Oh, there's some build error for sure. I forgot the semicolon. And let's see. So you can see that how easily by commenting the code, you can still have the code in your code, but it will not execute. This is just very interesting or it's an efficient way to test or debug your program. Just comment that and see if it's working. If it does, you can just delete the whole comment. If it doesn't, you can remove the comments and check again. All right. Now it's working. It's downloaded to my PLC, and to visualize that, I can open now local variables. So let me see. There you go. PLC is online, and I can open my local variables. Now you can see that A, if I press the first input, this is going to my A. So you can see that A is true. If I press my second input, this is going to B. Wait a second. There it is, B. And if I press my third input, it's going to C, and it's also actuating my output, you can see in my trainer. Right? And similarly, this works as well, A and B. So you have totally your way to write the program. I like this way because then you just have to assign the IOs in the beginning and outputs in the end, and then you can play with your local variables, because local variables are much easier to read because you can define the name very easily. Otherwise, working with direct addressing is not the best because it's difficult to understand what is written here. All right. So this was about the first exercise of writing a structured text for the following logic: x equivalent to a.b plus c. In the next video, we will solve some NAND nor XOR logic using physical I/O of the PLC. So see you soon in the next video. Bye-bye.